Hello guys, welcome back to Math Zone African Motives. We are still on our integration, and this is a question that we're going to work with from the question paper of November. Yeah, that is November 2022 exam. So we want to see how were we supposed to attempt these typical questions on our integration, since we are done with the introductions of each and every integration. So I want to challenge you guys to also do a favor, watch those videos, to do a favor to yourself by watching those videos so that you can be able to understand, because now this is a revision. So it's not like I'm going to go back deep into the explanation of the understanding that you're supposed to have. So that's why we have the introduction, so that you have a deeper understanding, and also you see a deeper explanation, all right, which is different from answering of the question papers direct, like what we're going to have here. But this is important as you are revising, so that you'll be able to understand. So this is question 2. Determine the integral of y with respect to x if we are given 2.1. So this is what we are given to integrate. That's 2.1, the integral of, right? Why is it too big? Or let me just try to reduce. I don't want it to be, okay, let me leave it like that. This is -2, all right? X cos x squared 2x. So it's gonna be with respect to x. This is what we are asked to integrate. Let me just try to reduce a little bit, guys. It's too much. Okay, so how can we integrate this? It's a product of two terms, an algebraic and a trigonometric. So we are back to by parts method, a product of two terms, and they're different terms. There is no magic that we can play around these two terms. So we're back to by parts method. Remember your by parts formula, the integral, it's going to be like this: the integral of f of x g prime x dx, which is equal to f of x by gx minus the integral of f prime, then we're going to have gx dx, like that. So meaning to say, we are going to need f of x, and it is best in this case to have our f of x as a what? As an algebraic, all right? We can have this, it can be obtained. So meaning to say, we are going to have something of this nature. I'm going to choose my f of x. So you see the problem is that the writings there are big, yet the paper that I'm using is very reduced, but I think you can even see, and you can see. So let me reduce, no problem. I thought that is going to be too much, no problem. I'm going to do it like this. Okay, so if we choose our f of x to be the algebraic, which is best in this case, which is minus 2x, it means the first derivative, since we need f prime, we're going to need the first derivative of this, which is -2, all right? Remember, guys, this is normal algebraic, okay? So there will be -2. And the remaining part, which is our g prime x dx, is this part of cos x squared 2x that is remaining here. So with that part, it means we are going to have g prime x dx from the cos x squared. So that's cos x squared 2x dx. Then we integrate both sides. So this is going to give us a gx. So the question is, how do we integrate a cos x squared? In order for us to integrate a cos x squared, remember, let us go back to our derivatives first. If you differentiate a chord, it gives us a negative cos x squared, right? If we differentiate a chord, it gives us a negative cosec. So if we integrate a cosec, it gives us what? A negative chord. And if you go on your integrals, I want you to go on the integrals there. If you go on the integrals, you check, let me just try and also work with your your formula sheet so that I show you the page. It's only that I do not have the PDF right now, but this way I think you understand what I'm saying to say it's the reverse. All right, where there's a cot, if it gives you minus cot squared, you reverse it, so it's going to carry a negative, so it's going to be minus cot. All right, so this will be minus cot 2x, but remember, integration, you divide, is the opposite of derivative, so you divide by what? You divide by 2. This one, we also had it in our N5, so it's not something new, guys. Also, all right, so this is it. We have everything, so we're just going to substitute into the formula. So that means here our integral was going to be f of x, whereby our f of x is minus 2x. So that's minus 2x times gx. Our gx in this case is minus cot 2x. So that's minus cot 2x over 2. All right, so you're going to multiply this minus the integral of the first derivative of f of x, which is the first derivative there. It was a negative 2 times what we got here, which is negative cot. So that's negative cot 2x over 2 like this with respect to x. Okay. We can simplify this part. If we can see here, we can check, we get negative, negative, this can cancel, 2 and 2 also can cancel, meaning to say you'll be left with x cot 2x. So that will be x cot 2x, all right? Minus what we're gonna have here is that we're gonna simplify again, negative, negative inside of the integral cancel, the 2 and the 2 cancel because this is in the numerator. The other one is in the denominator, so you're going to be left with the integral of cot 2x. This is what you're going to be left with inside of the integral with respect to x. So the question, how can we integrate this cot 2x? That is the question. Are we able to integrate cot of 2x? All right, cot 2x is very, very possible. If you check from your formula sheet, all right, on page number 2, all right, let me just remove this. If you check from your formula sheet on page number 2, on the bottom part, there is written a cot. There's a cot there. The integral of cot ax with respect to x is given as 1 over a. So it's 1 over a like this, ln that's sine ax. Sine ax like this plus c. All right, so I want to check that formula on page number 2 of your formula sheet. All right, that is when you are working with what? With a cot. 1 over a ln of sine ax. If you are dealing with the tan, it's going to be 1 over a ln sec. It will be sec ax. All right, but for cot, it's going to be like this. So meaning to say here, we are going to integrate this cot 2x using this way that we have here. And I don't know why did I write this far. All right, no problem. So this is going to be x cot 2x. Here, there's nothing that you're going to do. Cot 2x minus. Now we integrate this cot 2x using this integral that we are given here. So you say the integral of cot 2x is going to be 1 over a. So it's 1 over our a. It's 2x. This is our a in this case, ax. So it's 1 over a, which is 1 over 2. A here is 2, so it's going to be 1 over 2. The ln of sine ax, we are talking about the 2x, the ax. So it's 2x, all right? So it's going to be ln sine 2x like this. All right, so that is what you're going to have, plus the constant of integration. We are done. So whenever we are given this is what we are supposed to work with. This is how we are supposed to apply our integrals, all right? This is a by parts, but as long you work with the cot or a tan, you can use the formula sheet. The formulas are there. So you just need to know how to simplify each stage by stage. All right, so that was question 2.1. Let us check 2.2, x cubed cos, right? Another by parts. This is a by parts again. So these guys, they want us to work by parts. Well, this is another by parts again. All right. So it was by parts, by parts, by parts. You see, guys, you have to revise by parts. You have to revise by parts. All right, no problem. Anyways, that is 2.2, the integral of x cubed cos x with respect to x. All right, and that is 5 marks for that. We talked about this together. We had a question of similar nature, but it was, I think, a simplification of another algebra, but it had an exponent of 3. And I said, whenever you've got a condition like this, you are going to apply by parts 3 times. 3 times. The exponent there of 3 on the algebraic is 3. So you're going to apply your by parts by 3 times. So letting our f of x to be x, which is x to the exponent of 3, we are going to need the first derivative, remember, from our formula. That's to drop the exponent. So this will be 3x squared. Then from the g prime of x that is going to remain is going to be cos, which is cos of x with respect to x. So if we integrate this both sides, we are obtaining gx. So that's our gx. It will be the integral of a cos. And we know that if you integrate a cos, it will be a sine, okay? Sine gave us a cos, so cos is going to be a sine. So this will be sine of x, all right? We divide by what? By 1. If we divide by 1, it does not affect anything. So it's just going to be sine of x. Remember our formula. Let me just rewrite. Not for formulas, guys. I always rewrite this because I want you to see and understand this. So this is f of x, g prime x dx is equal to f of x by gx minus the integral of f prime x gx dx, like this. All right. Of which you are given this formula in your formula sheet, which is fine. So let us substitute and see. So it means here we are going to have the integral of, all right, this integral is going to give us f of x, which is in this case is x cubed. So that's x cubed times gx. Our gx is sine of x. So that's sine of x minus the integral f prime, the first derivative of f of x, which is 3x squared, gx, which is sine of x. So this is sine of x dx. So this is what we have. And we can even take this 3 out of the integral, which is going to be x cubed, the sine of x minus 3, the integral. If we take the constant out, you're going to be left with the integral of x squared, the sine of x dx. Yes, you can work with 3x squared as it is, but you can take it out of the integral. It's fine, right? So if you are to check here properly, we are supposed to integrate that, and that is the normal thing that you're supposed to have. We are supposed to have maybe something like x squared dx. We integrate x to the exponent of 4 over 4 plus. We are done with the rest of the part. But now it's impossible for us to just integrate because this part that we have here, it's a product again. Just like what we had a product here of x cubed and cos. This time it's x squared and sine. So meaning to say we are back again to the application of the by parts method. That's where I said if there is an exponent of 3, you have to apply 3 times. So now we've got an exponent, we have to apply again by parts method. So we have to choose again, just like the previous case that we had our f of x and our g prime x, just like the previous case, we apply or use our formula. All right, so letting our f of x to be the algebraic, what you choose to be your f of x in the first place has to be remain like that. So your f of x is still the algebraic, which is x squared. The first derivative there is going to be 2x. Then g prime x is the remaining part, all right, which is g prime x is what is remaining. So g prime x dx is what is remaining, is sine x dx. So this will be sine x dx. You integrate both sides to obtain gx. So the integral of a sine is a negative cos. All right, so this is negative cos x. Okay, so this is it. We are supposed to integrate this, all right? So you're supposed to apply our by parts method. So meaning to say we can do that by substituting, which is fine. Let me just do this on this one. But the next one, I'm going to do the shortcut. I'm going to, not like the shortcut, I'm going to integrate it aside. So for the first one, I want you to see exactly what you're supposed to do. You're supposed to have this as x cubed, the sine of x like this, minus 3 times whatever that you're going to have if you integrate this. And by parts, we are supposed to use our by parts formula, this one, which is equal to f of x of this and this and that and that. So this is it, f of x, according to this part that we are using, and this is the information now that we are using from what we have just calculated. This is the information that you are supposed to focus on. So from this information, our f of x is what? It's x squared. So this will be x squared times gx, our gx, which is negative cos x. So this is negative cos x, all right? Minus the integral of f prime x, f prime, which is 2x. So this is 2x by gx, our gx, which is negative cos. So it's negative cos x. With respect to x, whatever that you're going to do here, we are going to integrate with respect to x. All right, that's with respect to x, like that. So this is what you're supposed to have. You are substituting here because you're applying by parts. So instead of you let me just erase this, is fine, no problem. I think you have it, guys. Okay, so the case that I was explaining is this. Instead of you substituting direct like this, you could have worked this integral aside. You could have just integrated aside. Then you bring the answer here, all right, which is the one that I'm going to show you on the next stage. But for this one, I had to substitute direct, which is fine. But it's actually that is what you're supposed to do in exam. All right, they're like this. Okay, so you can expand x to the exponent of 3 sine of x. So if we expand by -3 is going to multiply with a negative there, so it's going to be a positive. So that's positive 3 x squared cos of x. Okay, then here before it's going to be negative, here negative, which is a positive. All right, so now we are left with the -3 here, and these two, we can take the 2 out of the integral. So if we take this 2, it multiplies with the 3. 3 is supposed to multiply everything. So, but because already there was a negative, it canceled. So now we've got -3 and 2. So it's gonna give us -6. The integral of, you'll be left inside with x, and here you'll be left with cos of x. So it's x cos x with respect to x. This is what you're gonna be left with. So take note, this is affecting the whole of this bracket. So -3, it affects the first part. Here it affects the second part. So that is what you're supposed to have. So this is the stage where we are, x cos x, like this. This is what you're supposed to work with. So the question is, how can we integrate this? Okay. This is what you're supposed to integrate, because we are still having the integration sign, meaning to say you're supposed to integrate again. But what you're supposed to integrate now, if we are to check it properly, it's a product again of two terms, an algebraic and a trigonometric. So meaning to say we are supposed to apply by parts again. It's a product of two terms. So this time I'm going to work it aside, guys, so that we do not have like a lot of things. You do not see like, it's a lot of things. No, it's not, it's the same thing, but it's just like for you not to see like it's a lot, but it's just the same thing. So in order for us to integrate x cos of x, let's say you're just given a question like this, what do? You apply your by parts method. Let my f of x to be x and my g prime x dx to be the remaining part, which is x cos x, which is cos x dx. All right, we'd find the derivative from our f of x, f prime x, which is 1. From x, we're going to get a 1. Then if we integrate both sides to obtain gx, if we integrate a cos, that will be a sine. Okay, remember, if you differentiate sine, it gives us a cos. So if you integrate a cos, it will be a sine of x. So this is what we have. From the formula, we saw that we are supposed to have this as f of x by gx minus the integral of f prime x gx. This is the formula that you're supposed to have from whatever that you're going to have this side. So meaning to say here, we are supposed to have our f of x, which is x. So that is going to be x times gx. This is our gx, which is sine. So it's going to be sine of x minus the integral of f prime, which is f prime x, which is 1. So this is going to be 1 times gx, whatever that you have, which is the sine of x dx, which is our gx here. So this is going to give us x sine x minus the integral of the sine of x dx. And we are supposed to integrate this part here that we are seeing here. We are supposed to have the integral of this. So meaning to say, this is the integral that we made of x cos x, but still we have something to be integrated. But this is what we just want to substitute here, what we got from the integral, this part. So what we got from x cos x is this one. So you're supposed to imagine stage by stage writing this. So instead, we can just calculate it aside, then we substitute. So this is what you're going to do. The rest is going to remain as it is, all right? That is, the rest is going to remain as it is this part, which is x cubed, the sine of x plus 3x squared cos of x, all right, minus 6 times this integral, which is the one that we are simplifying here, x cos whatever that we had, x cos x. This is what we got here. We got x sine of x minus the integral of the sine of x dx. At least we have got something that is, we do not have much working at this stage. All right, but you're supposed to write it stage at this point. You simplify just like what I did on the previous part. You say I have to substitute, then you expand the brackets on those integrals. So instead of us doing that, we can avoid, just do your integral aside. Then you write the answer that you got. But now we have to simplify. At least what we are simplifying is better than what we could have simplified before. So this will be x cubed, sine of x plus 3x squared, the cos of x, multiplied by negative 6 throughout. So it's negative 6 times x, which is negative 6x sine of x. Negative 6 and negative, which is going to be a positive. So that will be positive 6. The integral of, take note here, we have got the integral there. So it's going to be the integral of the sine of x dx, like this. So that is it. Of which now at this stage, it's easier because we can integrate the sine. All right, so we can simplify this to finalize our question. So that will be x cubed, the sine of x. So we've got x cubed, the sine of x, plus 3x squared cos x. So this is 3x squared cos of x, all right, minus 6x sine x, minus 6x sine of x. Then if we integrate a sine, we know that it gives us negative cos, all right? So the negative is going to multiply the 6, so it becomes a negative 6 cos of x plus the constant of integration. That's it. We have got full marks for that. We are done on that stage. So you see, you have to integrate 3 times. So I just hope you have that patience in exam. Do not leave this question because you see the exponent of 3, then you just say, it's no. Let's find time to do that and show stage by stage. Stage by stage, all these stage marks, they are being marked. All right. So that's that was it. That was it on this question 2.2. 2.3. I think we had this question on another class, if I'm not mistaken. If I'm not mistaken, 2.3. We had this question, guys. Okay. Anyways, let me do it. We are given the integral of 1 over x plus 1 into x plus 4, like this, with respect to x. And I said, when you're given this nature, or you think of the quadratic expressions. And when you think of those quadratic expressions, it means you have to end up with completing of the square in your mind. Completing of the square. So that is because these are 2 brackets. And if you expand 2 brackets, what do you expect it to have? Let us go back to our N3 and get a closer look. When we were expanding 2 brackets, what were we obtaining in our N3? We were obtaining a quadratic expression, a trinomial of this nature, ax squared plus bx plus c. So that's why I'm saying the moment you expand this, and you know that you're going to have a quadratic. So later in your mind, you must think of what? The completing of the square, because once you've got a quadratic expression, we have to complete the square. All right. So how can we obtain this quadratic expression of ax squared plus bx plus c? All right, we have to expand the brackets. So we're going to take the brackets only, x plus 1 into x plus 4, like this. All right, so let us expand the brackets and see x and x here. This will be x squared, x times 4, which is going to be 4x. We are done with x. We move on to 1. 1 times x, that will be positive x. 1 times 4, which is going to be a positive 4. So that will be x squared. If we add 4 and 1, that will be 5x plus 4. So this is what we are obtaining as our quadratic expression. And we are supposed to complete the square. And I said on completing of the square method, we've got two methods that we can apply, the formula, or to go back to the traditional method that we are used to, whereby this is supposed to be coefficient, which is 1, and the coefficient of x squared is already a 1. So what you're going to need is a half of the coefficient of x, which is positive 5. And then you square that. So half of 5 is 5 over 2. So this is 5 over 2 squared. So I told you guys, when you substitute back here, do not worry. Substitute as it is. You add and subtract as it is. Do not simplify. Yes, we know that this is going to give you 25 over 4. We know that. But so that you do not have confusion when you are factorizing later on, I talked about this. So this is going to be 5x. You add the square, which is 5 over 2 squared. So that you do not have confusion, just leave it like that, all right? Plus 4, we subtract the same square that we added. So we are going to subtract 5 over 2 squared. All right, so this is it. So the reason here is that on this quadratic that we see here, that we have here, we've got a quadratic expression up to this, which is a perfect square. So this one is a perfect square expression. For you to factorize that quadratic expression, you just focus on the first term and on the last term, first and last, the first squared and the last term, the ones that are being raised to the power of 2. That is why I was saying, do not simplify, leave it like that, so that you properly see the numbers that are being raised to the power of 2, which is x here, and here it's 5 over 2. You combine as it is, plus 5 over 2, everything squared. You have factorized that part. You have factorized. Then the rest you're going to use, you're going to simplify this part. So you can even use the calculator to simplify 4 minus 5 over 2 squared. So this is, 4 minus 5 over 2 squared. So just open a bracket, 5 over 2, like this squared. All right, so this is going to give us negative 9 over 4, right? That's negative 9 over 4. So we're going to get negative 9 over 4 like this. All right, so that means in this case, we are done. This is the part that we are going to use now on the integration. So like I said, this part of you having this nature, this one is up to you. It's up to you. It's in your hands. And we shall see later on, depending with the integral, if there are any adjustments to be done. But for now, this is what you're supposed to have. Just leave it like that. Okay. If I was to use the formula, because I also talked about the formula on the introduction, I said for the formula, you are going to apply this way from your ax squared, which is this part here of x squared plus 5x plus 4. Our a in this case is 1. Our b, so we've got a, b, and c. So we said if our expression can be written in the form of ax squared plus bx plus c, the formula is going to be given as 4ac. So it's going to be 4ac minus b squared over 4a plus a, all right, into the bracket of x plus b over 2a squared. So you're supposed to know this, because not so far we do not have this in our formula sheet, unless maybe in the coming years they are going to bring this, because they have this formula, so they can do that. So now let us substitute and see. It's going to be 4 times a, our a here is 1, times c, our c is 4, minus b squared, our b, which is 5. So it's going to be 5 squared over 4 times a, which is 1. All right, plus a is 1. So it's 1 into x plus b, our b here, which is 5. So it's 5 over 2 times a, which is 1. So that's it to the exponent of 2. All right, so if we simplify this, what are we going to have? We are going to need our calculator here. All right, let's simplify and see, put a fraction. That's 4 times 1 times 4 minus 5 squared. Or everything over 4 times 1. 4 times 1 is just same as 4. So this will be negative 9 over 4. So we've got negative 9 over 4 plus a 1 into this bracket. So that's x plus 2 times 1, that's a 2. So it's 5 over 2, everything squared. So this is the same, right? It's only the format here, but you can see that this is the same. It's only that the format, you can even rewrite the same way. X plus 5 over 2 squared, starting with the positive, then ending with the negative, which is 9 over 4. So if we are to check this, these two are just different ways of completing the square, and this is nothing much to be considered. We just need to know one of the methods. So I'm doing this because maybe some of us, we are using the formula, some of us, we are using the traditional method. So you're going to choose which one is best for you. Anyways, after you've completed the square, that is where the question starts. After that, that is where our integration, remember, the question is on integration. This is not integration. This is our N3 stuff. Now we are back to integration. How are we going to integrate what we got here? We got, so this will be the integral of, so we have got the integral of 1 over, in this case, this whole part that we had here. It was simplified, expanded, gave us this expression, and after that, completed the square. This is what we got. So we're going to write what we had from the completing of the square, which is x plus 5 over 2 squared, like this, minus 9 over 4. All right, with respect to x. So this is what we're going to have. We just take what we obtained after completing of the square. This is what we got, either way from the formula or from the traditional method of completing of the square method. Now this is where we are. All right, since here I'm not going to need this, let me just remove so that we properly see where we are working on. At this stage, like I said, that is where your integration is now starting, because you have to figure out the best integral to work with. Where, okay, let us go back to our formula sheet. I just hope I have this on this one. I think I inserted this here. I explained about these formulas before. These are the formulas that I talked about whenever you're dealing with completing of the square. And you do not use these formulas, you must ask yourself, something. And whenever you're dealing with completing the square. So our question at the last stage, we are supposed to integrate. Remember, we are now at a stage where we are supposed to integrate. It was given as 1 over, we got that as x plus 5 over 2. It was x plus 5 over 2 squared. Okay, I just hope it's like this. Minus 9 over 4 like this. That was our question. So we want to check what is going to be the best formula to use here. All right, you have your formula sheet, you are checking which one is the best. Here is totally out, there's a square root of the format. Here there's a plus, and there's no way I can factor out this to give us a plus, so this one is totally out. Here there's a square root, it's totally out. All right, on this one, yes, there's an opportunity for us to have this because we can factor out a negative so that this gives us this format here, this formula. So this is the one. Here there's a square root, it's out. Here there's a square root, it's out. So this is the one that we can think of now. But if you check, this formula is not exactly what we have here because it's given as the integral of dx over a squared minus b squared x squared. they are supposed to start with a constant squared, but here we are starting with x. So we are supposed to start with this constant. So we have to rearrange. Okay, let us go back, and I'm just going to write the formula and also explain with what we are given there. So if we check from the formula is stating that, all right, let's remove this so that we properly analyze our formula and what we are given. If we check it properly, our formula is given as the integral of dx, it's given dx on top over, then it's given as a squared minus, this is the most important part, a squared minus b squared x squared, where they are saying it is going to give us 1 over 2ab, the ln of a plus bx, the ln of a plus bx over a minus bx, like this. This is what we are told. This is what we are given from our formula sheet. So I want us to work with this. If we check the presentation here, we are supposed to have a constant, which is being the 1 being squared, starting here and being a positive. And this format is not the one. So you're supposed to take out the negative here so that our constant becomes a positive. So we are supposed to factor out a negative. If we factor out a negative, it means we are going to remain with the integral of 1 over, we have factored out the negative. So this is going to be a positive. Negative, negative, it gives us a positive. So that's positive 9 over 4. Positive and a negative, it gives us a negative. So it will be negative x plus 5 over 2 squared, as it was before, with respect to x. But we are supposed to have this format, like a squared, properly see the a and the b and the x. So 9 over 4 is the same as 3 over 2. Remember that as a number raised to the exponent of 2. So here I'm just writing this, we are done here. But I'm just rewriting in a format so that we properly see our format. So, and I said 1 times dx is the same as dx. So there is just same as we've got dx over 9 over 4, which is same as 3 over 2 squared. If we square this, we get 9 over 4. Minus, we are supposed to have b squared, which is a constant. So we're just going to write 1 squared since we do not have a number there. So it's 1 squared. All right, x squared. The x is the part that we are given already, this part of x plus 5 over 2 squared. So what it means is that we have, in this case, this part here representing our a, which is a squared. This part representing our b, which is b squared. This part, the whole of this bracket of x plus 5 representing our x, which is x squared. Once we have this format, we can apply this formula. That's where this formula is used. It is used whenever you have this format. So this is what we have, 1 over 2ab. So it's going to be 1 over 2ab. Our a is 3 over 2. So it's going to be 3 over 2 like this, times b. Our b is 1. So it's 1 there, okay? Ln of what? So you're going to have ln of a plus bx. Remember our a, 3 over 2. So that's 3 over 2 plus bx. Our b, it's 1. So it's 1 times x. Whatever x represents is the whole of this bracket, which is x plus 5. So this is x plus 5 over 2. No, guys, we did this question before. Now I remember these values very well. No problem. A, again, which is 3 over 2. Okay, that's 3 over 2. Let me just remove this. 3 over 2 minus bx. Our b, remember, it's 1. So it's 1 times x, which is x plus 5 over 2, like that. So that is how you are going to integrate, as long you have the formula, all right, plus the constant of integration. That's it. So this whole integral, this part, is going to give us this. So if we simplify this, guys, on our calculator, even hereby, so we can cancel 2 and 2. We remain with 1 over 3. So it's going to be 1 over 3. All right, so you're going to have the ln of, we have this part that is to be simplified. So like I said, there's no need for even you expand the brackets, and just leave it like that. You can just leave it like that. 3 over 2 plus 1 into the bracket. If you want, you can expand the brackets. If you want, it's up to you. All right, so this will be the bracket of x plus 5 over 2 like this, over the minus 1 is just same as there is what? A negative like this, x plus 5 over 2. So do not worry about simplifying the bracket, just leave it like that, all right? Plus the constant of integration. All right, so that was the whole situation that we had. We were given a hidden quadratic expression. It was hidden. The quadratic expression was hidden, and we had to pick it out, complete the square. After completing the square, we have to figure out for the formula which best suits what we are given here. There is only one formula of all the formulas that I showed you, and I explained that before, that there's only one formula that you're going to use there. All right, so did you put the negative here? Oh, guys, we have the negative. Don't forget the negative there. The negative, there's a negative there and negative there. All right, yeah, like that. Now it makes sense. So just like that. So you see, guys, N6 is a lot, and you have to be careful, okay? I think that's it. Yeah, if you see anything, let me know so that we can talk about that. If there's any question that you see, somehow that you do not understand, but that is how we're supposed to have this question. Okay, let's check another question. That will be 2.4. All right, and we had, I think, a similar question. Maybe, if I'm not mistaken, it was for cos. Maybe it was for cos, where we are integrating a sine to the exponent of 5, or it was a cos to the exponent of 5. Like I'm saying, now I do not know what exactly was our question before. But anyways, this was a sine to the exponent of 5 of 3x with respect to x. And we said when we are working with a sign like this, we have to figure out, whenever work with the type of the sign to the exponent of max. Remember that introduction where we said we have to figure out, is this m an odd number, or is this m an even number? Even for a cos, you have to figure out, is this n, it was n, or I wrote it in terms of n, if it is like that, not a problem. So if we check the n or the m, or whatever that you have here is an odd number, you are dealing with an odd exponent or an odd power. So whenever you are dealing with an odd power, I told you guys you're going to use the identity of sine squared ax plus cos squared ax, which is equal to 1. So you work with this in favor of what you are given. So here it's in favor of sine. So we have to make sine the subject. That means sine squared ax is equal to 1 minus cos squared ax. So this is what we are supposed to be thinking of, because we are working with an odd exponent. So as long this identity is not used, you have to ask yourself a question: how is this possible that I did not use this identity? All right. And in order for you to use this identity again, as you're asking yourself, in order for you to use this identity, you must have a sine squared. So now it is the question, how are you going to split this into a sine squared? All right, it is going to be like this, sine squared 3x. So in order for us to get to the exponent of 5 from, let's say, x to the exponent of 5, it is the same as x to the exponent of 2 to the exponent of 2 times x. Okay, which is x to the exponent of 4. We multiply here, 2 times 2, we get a 4. Then we add 1, which is a 5. Which is the same thing as we could have expanded like this, x to the exponent of 2 times x to the exponent of 2 times x. But this one, the way of expanding this, separating x squared and x squared, you use this type of a format when you are working with a cot. It's cot to the exponent of 4, whatever that you are given, or it's a tan to the exponent of 4, whatever that you're given. All right. All right. So in this case, in order for us to get this, is going to be a 5 like that. Okay. In order for you to use this one, where you write it once then you square it. This is best when you are working. You use it when you are dealing with a sine and a cos. Sine to the exponent of 5, or it's a cos to the exponent of 5. That's where you use this format of squaring and having that x squared and you square it. But on a tan, you expand them separated. So what am I trying to say? I'm trying to say here, we are given sine to the exponent of 5. So this is going to be sine squared 3x. Then we square this, just like x squared squared again. Then we multiply by the same sign. So it's going to be sine 3x. We haven't changed anything because 2 times 2 is 4. Then 4 plus 1 on this exponent, it gives us what? It gives us a 5. So we haven't changed anything. But if it was a tan, it was going to be like this for a tan. It was going to be tan. In fact, you don't expand it like this one. It was going to be tan squared 3x times this one. You combine it together, x squared and x, they give you x to the exponent of what? X to the exponent of 3. So it's going to be tan to the exponent of 3x. That is for tan and for a cot. You expand it that way. But for tan, but for sine and cos, you expand it in terms of a square. All right, you square that sign again, sine. So meaning to say, if it was sine to the exponent of 4, we're done like this. We're just going to leave it like this. Sine to the exponent of 2 squared. It gives us sine to the exponent of 4. You don't write it as sine 3x times another sine. No. You don't do like that. All right. But here it was a 5. So meaning to say, we're going to have it this way. All right. So I think we are together, guys. Okay. So this is it with respect to x. Now that we are at this stage, remember the purpose of expanding, of splitting this way, is so that we have this equivalent to what? To the identity of sine squared ax, which is equivalent to 1 minus cos squared. So it means in place of this, we can now substitute back our identity. So this is going to be the integral of, we substitute our identity. That is going to be 1 minus, so this one is going to be 1 minus cos squared. So it's going to be cos squared 3x like this. All right, squared. Then times sine 3x outside. So this is sine 3x dx. So what does it mean? It means we are supposed to expand this 1 minus cos squared 3x squared. There's a squared. So I talked about this identity, a minus b squared, which gives us what? A squared minus 2ab minus 2ab plus b squared. If this is a plus, this is going to be a plus also. All right. So that is the idea of this. So meaning to say we can expand because this is the format that we have. This is our a, just like this part. And this is our b, just like the previous part. All right. Being everything here being raised to the exponent of 2. So it means it can be expanded in this case. All right. It can be expanded where we are going to have, in this case, if we expand this, it's going to be a squared, which is the first term squared, 1 squared, which is 1, minus 2ab, so it's minus 2a, which is 1, times b, which is cos. This is our a, this is our b, so it's going to be cos squared 3x. All right, plus b squared, which is the last squared, our last, which is cos. If we square this, if we square cos squared 3x like this, and we square it, what do we obtain? 2 and 2 multiplies, it's going to be a 4. So this is going to be plus b squared, which is going to be cos to the exponent of 4 of 3x. All right. So this was the expansion of this bracket squared. But already outside of this bracket, there is a sine 3x dx. This is not being affected, so it's going to remain as it is, sine 3x dx. Now that we have expanded our brackets, now that we have expanded this bracket, it means we can get this into consideration, the sine 3x dx, this remaining part here. Expand it throughout of the integral, each and every part that you are given. It means we're going to have 1 times sine 3x dx. It's going to be sine 3x dx. We integrate that, okay? Minus 2 multiplies this again, so it's going to be minus 2. The integral of, so this will be cosec, this is cos squared, and this will be sine, so it will be cos squared 3x sine 3x dx. We integrate this, all right? The same thing, the cos and the sine will multiply each other, so it's going to be a plus the integral of cos to the exponent of 4, 3x times the sine, which is the sine of 3x dx, like this. Okay. Once you're at this stage, then we can be able to integrate. All right, the first one, we can integrate direct. The first part here, we can integrate direct here. But here we have to apply those substitution method, guys. Remember our substitution concept, all right? So for us to properly do this, we can integrate, no problem. Integrate sine. If you integrate sine, it gives us a negative cos. So that will be negative cos 3x over 3. All right. Now this is, we are supposed to have that substitution. In fact, we are supposed to have our substitution on these two. But if we check, it is the same thing here. That is happening. We've got the sine 3x, which is the same as the sine 3x here. And the cos is the one that is being raised to a certain exponent. So we can choose to use that cos as our u. As the u, the one that we can use to cancel this sine 3x. So we can choose that, remember, by substitution method. All right. So you choose u to be cos of 3x. That means du dx, the derivative here is going to be minus 3 sine of 3x. Derivative of cos, it's a negative sign. Then we make dx the subject. If we make dx the subject, it's going to be minus du over 3 sine 3x. In actual sense, it's supposed to be, the minus supposed to be like this, minus 3 like this. This is what you're supposed to have, which is fine. Just leave it like that. All right? Or you can just take the negative on top like that, okay? Which is one and the same thing. So if we were to substitute back this dx that we got here, if we are to bring it back here, all right? We are to bring back the dx here, which is the minus du, all right? Which is the minus du over 3 sine 3x. What was going to happen? The sine 3x and the sine 3x was going to cancel. Then you remain with the d, because this dx is substitute this. So here we're going to remain with the minus 1 over 3, this one. Where do you take it? Out of the integral. So if you take it out of the integral sign, it's going to be minus 1 over 3 times a minus 2. So it's going to be a positive 2 over 3. We take it outside, it multiplies with this. So it will be a positive 2 over 3. So we are left with the integral of cos squared, of which cos is represented by what? By u. So it's going to be u squared with respect to what? With respect to u. Remember, we have substituted this dx with the equivalent of that dx. All right? So that is what you're going to do on that part. So you have to integrate this. So it is the same thing that you're supposed to do also here on this part. Remember, our u is cos, guys. Remember, our u, I have erased this. Remember, we said our u is cos 3x. All right, I'm just going to do this. It is the same thing. In place of this dx, we're supposed to substitute minus du over 3 sine 3x, or du over minus 3 on, or if you want to write it down, that's fine. So the sine 3x and the sine 3x we're going to cancel. So we take the minus 1 over 3 out of the integral. So it's going to be minus 1 over 3 because it's a positive. So positive, negative, it gives us a negative. The integral of, there is a cos there to the exponent of 4. And what to represent cos? It's a u. So that's u to the exponent of 4. So you're going to integrate this with respect to what? With respect to u. That is what we're supposed to have in actual sense. So you show those stages aside. There's no need for that, right? Just show them aside. At this stage, you're supposed to integrate, but here take note that you have already integrated here, and you got this one. So you're not going to integrate this again. You're just going to remain as it is, minus cos 3x over 3. Then this is the part that we have to integrate. We still have the integration sign. So we have to integrate here. We also have to integrate here. All right. So let's integrate and see. So this will be 2 over 3. The integral of u to the exponent of 2, we add a 1. So it will be u to the exponent of 3 over a 3. All right. Minus 1 over 3. So this will be minus 1 over 3. The integral of u to the exponent of 4, we add a 1. So it will be u to the exponent of 5 over a 5 like this. Plus the constant of integration. We do not have anything to be integrated later on. All right, let us combine and see what you're going to have at the end. So this will be minus the cos of 3x. So this is minus cos 3x over 3. All right, plus, remember what u represents. U represents cos. So if you multiply the numerator, this and that is going to be 2 over 3 times 1 over 3 is going to be 2 over 9. 3 times this 9. But u is represented by cos 3x. So it's going to be cos to the exponent of 3x. Minus 1 over 3 times 1 over 5, we get minus 1 over 15. So that's 1 or minus 1 over 15. But u, remember, is representing what? Cos 3x. So it's going to be cos to the exponent of 5 of what? Of 3x. So that's it. That's it. We have integrated everything properly at this stage. We have integrated everything properly. That is what we call the integral of the trigonometric of a sine, which is the same as for a cos. All right, you use the same conditions, same situations, and the algebraic, the substitutions at the end. But what is important, check the exponent first. Is it an odd or an even? Whenever you are dealing with an odd exponent, this is the identity that you are supposed to use. If it was an even, so what is the question is, what identity are we supposed to use? All right, from our introduction, we said whenever n is equal to 2, or we have got a condition where n is equal to 4, where these are even exponents. Mostly when n is equal to 4, because when n is equal to 2, it's there in your formula sheet. So mostly when n is equal to 4, we are going to have our sign. We are going to use this identity. Sine squared ax is equal to a half minus a half of cos 2ax. If it is a cos, it is going to be cos squared ax is equal to a half plus a half of cos 2ax. I explained these identities in the introduction. So like I said, if you still have a challenge, make sure that you watch the introduction so that at least it can help you in simplification. But if it is an odd like this, you use the one that we applied of sine squared plus cos squared is equal to 1. All right, that's it. 2.5, integrate again. So like I explained before, this is a bypass that is just given there. They want us again to use bypass 3 times in one question in one. Okay, it's fine. The integral of 5x e to the exponent of minus 2x with respect to x. So we can just choose our f of x already to be x, which is direct. All right, we can integrate e to the exponent of x. Is that so? It's a question. Can we integrate e to the exponent of minus x? It's possible for us to integrate that, but we have to consider there's a lot of things to work with there. There's a lot of things to be considered. Okay, which is fine. I go to my 5x. Is it possible for me to integrate 5x? Is it possible? Yes, I can integrate 5x. I can also find the derivative of the same 5x. So it's a choice that we have, or that we can choose to work with. Which one is best? Because all of these can be integrated and also can be differentiated. I just hope we are together. All right. If I use this as my f of x, if I use 5x, it's going to be easier because we eliminate the idea of reintegrating again. Okay, let me explain this way. I just hope you understand me, guys, but I talked about this before. Okay, so this will be a 5. Let's go to e. The g prime dx is going to be e to the exponent of minus 2x with respect to x, and we are supposed to integrate both sides so that we obtain this. So the question is how, if we integrate this, okay, we're going to obtain our gx, which is fine. But what about e? What about an e? This is going to take us a stage because the integral of e is given like this. The integral of a to the exponent of f of x with respect to x is given as a to the exponent of f of x over the first derivative of f of x ln of a. So for an exponential, it's an advantage because we can just remain with this, then we find the derivative, all right? It's something that is an advantage when you're dealing with an exponent. But this is the format that you do if you are someone who does not know how to integrate an exponential direct, because on your formula sheet, you are not given the integral of e. They did not even write that. So you're supposed to know this from this one, all right? Or you're supposed to know direct the integral of e, all right? That is, it's going to be e to the exponent of minus 2x over the first derivative of this, which is minus 2. Okay, we leave it like that. If I was to use this formula here, it was going to be like this. E, which is a, here, e to the exponent of minus 2x over the first derivative, which is the first derivative here, which is negative 2, times the ln of a, which is the ln of the base, which is the ln of e, and ln e is 1. Remember that ln e is 1. So we can take the negative on top, as I always say, so it's going to be minus e to the exponent of minus 2x over 2, like that. So you can simplify and have the same answer, just like what you could have integrated by knowing your integral of e. That's what I'm trying to say if you know your integrals direct, it's an advantage. But if you do not know, therefore, know the formula, all right? So this will give us minus e to the exponent of minus 2x over 2. All right. So this is what we got from our gx, okay? And from the first derivative, we got this. So remember, by parts formula, whatever that you're going to integrate is going to be the product of f of x by gx minus the integral of f prime x gx dx. All right, the integral of this and that, whatever that you have there, which is the one that we splitted here. So this is going to be f of x, which is 5x, times gx, we got negative e to the exponent of minus 2x. All right, everything over 2 minus the integral of, so you're going to have the integral of the first derivative, which is 5 times e minus e, right? Minus e to the exponent of minus 2x over 2, like this. So this is what you're going to have with respect to x. Okay, so that is it. And we can integrate and finalize our answer here. So this one, you can multiply negative 1 over 2 and 5. It will be minus 5 over 2x e to the exponent of minus 2x. Okay, negative gives us a positive. So it's going to be positive 5 over 2 out of the integral. Then we integrate what is remaining, which is e to the exponent of minus 2x with respect to x. All right, if we check on our integration, you have this integral of e, we got minus e, whatever that you have, to the exponent of minus 2x over 2. So we have the answer already of this. So it's a repetition that we already have. So it's going to be minus 5 over 2x e to the exponent of minus 2x plus 5 over 2. We write the answer that we got. If we integrate this, we're going to have minus e to the exponent of minus 2x, which is this part that we substituted before. So that's minus e to the exponent of minus 2x over 2. So we have integrated this. We can integrate that. So we have integrated. We know there's no need for us to integrate again. Already the integration is done. So that will be minus 5 over 2 x e to the exponent of minus 2x. We can multiply this. What are we going to get? Plus and minus, that will be a minus. 5 over 2 times 1 over 2, that will be 5 over 4. So it's going to be 5 over 4 e to the exponent of minus 2x plus the constant of integration in that case. Okay, so as you can see, that's how the questions are given as. That's how the questions are given as. And you have to be very, very careful, each and every stage to be properly presented and shown so that they see what exactly are you saying? What exactly are you writing? Each and every stage has to be properly given up to the last stage of your simplification. So that was our question, November 2022 exam, question number 5. So I just hope we're going to have more of these typical questions so that you see that it's just one and the same. Once you revise 4 question papers or 5 question papers, 3 question papers, you are done. You can be able to answer any question that you are given, any question, because it's a repetition throughout. You see that it's going to be a repetition from now onwards.